Hello, people. Thank you so much and welcome back. Today, we'll talk about the transfer function that we use in Six Sigma. You all know that when we are using Six Sigma, we use two main things. One, what is the strategy? And the second is the methodology. Strategy, we are using y is equal to f of your x, and the methodology we use DMAC. So you need to apply, or you can apply the DMAC methodology when your strategy of y is equal to f of x is inbuilt or it's a clear. So y is equal to f of x is also called as a transfer function. What is that? What do we do? In this situation, if we see y is the output variable, which is the result you are looking for, that you want. X is the input factor, whichever is necessary to get the output. Maybe 1x or maybe more than one input you need to deliver the final output. And f, which is the function of the process that will take the input and make them into the desired output. So what is the function of the process? Process is, it's a set of interrelated activities which convert input into the output. That's what the transfer function of the y is equal to f of x is. So y is equal to f of x is a representation of a mathematical formula used when examining different possible outcome based on the inputs and the factor used. Outcome is your y variable. So y stand for the output, f stand for the function of the process that we are using, and x represent the input used in the formula. So this formula associated with Six Sigma, this is also called as a breakthrough equation. So we use the formula to find out which y will send us to the optimal or the best output, which means we will be optimizing by using the equation y is equal to f of x. So what are the settings of x if we keep at a label so that we get the desired output or the y variable. So in define phase, we gather the desired outcome as in y in DMAC stage. In the measure phase, gather the possible input x as well as the measurement of input x and the output of y, which means in the define phase, we are trying to find out what is my problem. What is my calculation? Basically, what is my output metric, y, which we are trying to improve, that we connect in the define phase. In the measure phase, we try to identify by using the cause and effect diagram or fishbone analysis or brainstorming what are the possible axes may have a significant relationship with the y, which is also called as a probable root cause. In analyze phase, all these possible axes or the probable root cause with the help of data, we validate the relationship between y and x. After validation of this relationship, when you are validating through the statistical analysis, these are called as a validated root cause. In improve phase, many of these root causes or the x variable, which has a significant relationship with the y variable, you have already identified in the analyze phase, but not necessarily you can improve everything. So the things which you cannot improve, we will drop here. And the things which you can easily improve will take to the next stage as an improve phase. So those are called your actionable root cause. Now, when you move to the control phase, you monitor the y over the time, that how your performance is going, and you monitor and control all your x's as well. X means input variable. That if your x variable remains in your control, then the y will remain in your control. That is what the transfer function f y is equal to f of x is. So y is your dependent variable, f is the function of the process condition, and x is your independent variable. So your independent variable, how much impact it is giving you to dependent variable, whatever the changes is happening in your independent variable x, how it is reflecting in the changes in the y variable, is what your transfer function explain, the equation y is equal to f of x. Thank you so much. I will see you in the next session.